Yeah, good evening. Ready? Okay, so in 5 minutes, let us recap whatever we have studied yesterday. So in the yesterday class, we started with the origin and evolution of the Earth crust. Okay, and we saw those stages. I mean, we talked about we talked about density differentiation, right? Then you magnetic differentiation, and then those events which are taking place internally and externally. That means internal environment of Earth and sand, right, and external environment of Earth. Then after that, we started with the physical condition prevailing inside the Earth and sand. That is to do with the study of the Earth interior. That means the whole body of the Earth interior. Okay, so in the topic of origin and evolution of Earth crust, we only dealt with one part of the Earth interior, that is the uppermost layer of Earth interior. Okay. Now we are trying to understand the whole interior. What type of material we have inside the Earth, what is the nature of arrangement of those material. That means we have to deal with two broad aspect of interior of Earth, that is the structure of Earth interior, which means the arrangement of material inside the Earth, right? The layered arrangement of material inside the Earth, which is called as structure, and composition deals with the material content. That means what chemical composition of material you have inside the Earth at different depth, right? At different depth. So this is what we have to study, and we all know that we have a problem here. The problem is that we cannot have the application of that philosophy called seeing is believing. That means we cannot establish direct contact with Earth interior. Okay, so we are dependent upon the indirect sources for our study of Earth interior. Okay, direct sources are having limited significance. I told you about the deep sea drilling project, where we have been able to drill up to 12 kilometers of depth, and that is just a negligible distance in comparison to I would say in comparison to the radius of the Earth, which is 6371 kilometers. Okay, so it is just like scratching your hair and trying to understand the whole body. Okay, that is not possible. Second, I said you have volcanic eruption. Volcanic eruptions too have limitation because they give us an impression as if the Earth interior is in liquid state, but actually the Earth interior is not in liquid state. So that is again half information, misleading information about the Earth interior. Then we go to the indirect sources, and we talk about those indirect sources, what role they play, how they contribute in the study of Earth interior, and then we took into account the temperature factor, the temperature measurement, density, and pressure measurement, right? But again, these three geophysical phenomena would not be able to tell us the whole story because they have different kind of relationship inside the Earth. I told you generally what happens when you have temperature increasing, with the increasing temperature condition, the density of the substance falls, right? But actually we know that we have density, pressure, temperature, all three geophysical phenomena, they are having an increasing trend inside the Earth. That means with every kilometer of increase in depth inside the Earth, the temperature, pressure, and density condition increases. Okay, so this is again a problem. That means again we are going to be misled by taking into account only these three geophysical phenomena, the natural phenomena, that is pressure, density, and temperature. Okay. Then we took into account the role of meteorite. Meteorites tell us about the Earth interior. We study the structure of the meteorite, and we find that the meteorites are having highest proportion of iron, magnesium, these denser element in their top part. And we know that we do not have such concentration and distribution of material inside the Earth. We have densest of the substance found where? In the innermost part of the Earth, right? That is your knife, nickel, iron, yes or no? In the innermost part of the Earth, that is your inner core. Okay. So again, the study of meteorite is not helping us. Yes, that helps us in understanding the material composition inside the Earth. But it does not help us in understanding why the materials are arranged the way it is arranged inside the Earth. Okay. This is the problem we have with the study of meteorites. Okay, so again they are not telling us the whole story. Then we followed two more technique. One is your magnetic survey, and I told you under the magnetic survey that is one survey which is done on the surface of Earth, and we take into account two surfaces. One is your continental surface, that means land area, and the other is your oceanic surface, right? And we know that oceanic surface are made up of those denser material. They are having more ferrous mineral, and that is the reason why the gravitational pull over the oceanic crust is relatively higher than the continental crust, right? And I told you just follow a simple exercise. You allow an iron ball to drop upon the land, and upon the oceanic crust, you will find the velocity of iron ball being higher upon the oceanic crust. That means the pull over the oceanic crust is greater. Okay. Then we came to one more technique, and that is your gravity anomaly, right? We have unequal gravitational force at different places on the surface of Earth, and we know that it is mainly because of the circumference of the Earth interior, right? Circumference of the Earth interior, where you have gravity being lowest at equator and highest at poles, right? Again, that does not explain I would say the distribution of material inside the Earth. That means we cannot understand what is the exact mass of material distributed at equator and near the pole, right? But in general, that gives us a sense that you have compression of mass. You have high concentration of mass near the polar area, and you have lighter material being found near the equator. But that is not the case. We know that we have this crust having two parts. One is your continental crust, the other is oceanic crust, right? This whole lithosphere is composed of continental and oceanic crust, and that lithosphere is gliding upon the asthenosphere, right, which is in constant motion, right? So again, that is of limited use for us. So we go to one more natural phenomena, and that is your seismic evidences, right? Seismic evidences form the major source, or they are the most scientific source. They are the natural source. They are the comprehensive source telling us about the whole Earth interior, right? Why? Because the seismic waves are able to travel in all part of the Earth interior, and by studying their behavior. When I say behavior, that means they are changing velocity at different depth of Earth interior. Second, their path of movement, right? That means travel path. Okay. The travel path, the travel path is guided by two principles. One is refraction, the other is reflection, right? So this is your seismic wave. The study made upon them, and observing their behavior, right? Observing their velocity change at different depth of Earth interior, the travel path changes at different depth of Earth interior. We are able to generalize. We are able to draw an inference about the Earth interior, and we say that the Earth must be like this. Okay. So they are the most plausible source of information, the most scientific source of information, one source which is able to tell us the whole story about the Earth interior. That is why we rely upon seismic evidences. We rely upon seismic waves to scan the Earth interior. Okay. So now we have to talk about the seismic wave. So first of all, in 5 minutes, I'll talk about the role of seismic wave in the study of Earth interior, and then we'll talk about the seismic wave itself. Right? That means the properties of seismic wave. Based on the study of those properties of seismic wave, will be scanning the Earth interior. That means we'll take into account the property of those seismic wave, and then we'll try to scan the whole Earth interior. Okay. So let us understand this first. The role of seismic waves in the study of Earth interior. So I'll just highlight the points. Point number 1. Now the first point is very simple to understand. Now before I start talking about this, let me, okay, you all are busy in writing. Fine. You complete this first. एक बार हो जाए तो मुझे बताना. Done? Okay. Now before I start with this, let me share one important I would say important aspect of our study which we are following in geomorphology. Believe me, geography is just opposite to any other subject, right? Any other subject. Why I'm saying this? Because geography starts with the most difficult part, right? The most complex part. The most complex part of geography is geomorphology, right? Once that part is over, especially in the interior condition, because the things are not observable, right? We cannot see them, right? Once you come onto the surface, when we deal with the landforms, the things are going to become easier, right? And once you complete the geomorphology part and enter into climatology, it will become more easier, right? So this is the most complex part and the most, most difficult part to handle, right? So you have to be patient here, right? Take small steps only, bit by bit. Try to understand those things, and just see whether you are able to answer those questions or not, right? Whatever questions have been asked in previous years, right? You have collection of all those previous questions, right? For I would say almost for 40 years, right? Just go through those questions, right? Question paper, and see whether you have any question coming from this topic or not. When I say the topic, that means the first topic which we covered, that is your part of the syllabus, the origin and evolution of the earth crust. See what type of question has been asked, right? Then find by yourself, do you have sufficient understanding of the concept or that phenomena which is being asked in the question. If you can get that sense of satisfaction, that you can assume that you are moving in right direction, right? This is what you have to do, okay? तो थोड़ा सा आपको पेशेंस रखना पड़ेगा. You have to hold on, right? Because we are not going to be mesmerized by all those developments in saying initial 20-25 days, right? 20-25 days are going to be very crucial, right? And that is the central pillar of geography. I told you, central pillar, right? If you are having a shaky presence here, if you are not having a developed footing here, right? Obviously, you will have a shaky presence in the entire subject. Why? Because problem in geomorphology means problem in climatology, right? Because you know that all other components are dependent on lithosphere, right? So this is very crucial that we take small steps and try to understand those things in a simplest manner, right? Simplest manner. And there are a lot of interpretation, right? You'll find different data in different sources. We are not going to worry about the data, right? We are not going to worry about the data. Why? Because those are only inferences, those are only generalizations, those are only conclusions we have made based on the observation of some behavior we see near to the surface, right? Many of those things are generalization. So you have to accept this. Like yesterday she asked about water vapor, from where that water vapor is coming. But I told you we are assuming that the volcanic eruption in geological past too would be releasing the same nature of material which is now being released by the volcanoes in the world, right? So this is what you have to understand, that the part is complex, but that is doable, that can be done if you stick to the plan, if you hold on and then show more maturity here, right? So now coming to this part. We are talking about the role of the seismic wave. The first point is very clear, right? No doubt about this. That is right. I mean, it did not, as I said, it did not be explained. I mean, it does not require any kind of explanation. Second, come to the characteristics, right? Under the characteristics, you have to focus on two things. One is behavior, and the second is travel path, right? Talking to the behavior part, you'll find behavior is mainly focused on the velocity change, right? The velocity change we see for those seismic waves at different depth of Earth interior. Those seismic waves witness a velocity change with a change in density inside the Earth, right? And that can be a change in density or that can be a change in medium. Maybe the seismic waves are moving from solid to the liquid state, right? We know that there are belts inside the Earth, there are zones inside the Earth which are in super solid state, which are in liquid state. You have solid state of matter also, and then you have a zone which is having matter in neither solid state nor in liquid state, right? Semi-molten state, that is your atmosphere. Okay. So why this is so? We'll talk about that later on, but this is what the information we get from the seismic wave when they are studied by those instruments like seismograms, and then the graphical representation of those data collected by the seismograms are done by one instrument, we call it as seismogram. Okay. So this is your first point. Second, the boundary along which the change in velocity of seismic waves are observed, such boundaries are called as seismic boundaries or seismic discontinuities, right? These are the seismic boundaries or discontinuities we have taken into account to classify the Earth interior, to divide the Earth interior into different layers, right? Into different layers. Like you must have heard about Moho discontinuity, Gutenberg discontinuity, right? So based on those discontinuities, we have been able to divide the Earth interior into three broad layers, that is crust, mantle, and core, right? These three broad layers are further subdivided on the basis of observation of those discontinuities found within those broad layers, and then they are further subdivided into two sub layers each. That means crust into upper crust, lower crust, mantle into mantle into upper mantle and lower mantle, and then you have core that is divided into outer core and inner core, right? So these are the discontinuity we are going to see, and that will help us to classify the Earth interior, divide the Earth interior into different layers. Now coming to the travel path, you'll find that the travel path is again controlled by what? Again controlled by density change, right? Density change. Either the medium inside the Earth is changing or the density of the substance is changing, and the seismic wave undergo either refraction or reflection, right? I said refraction or reflection. Both P and S wave, they are your body waves, we'll talk about them. Both P and S wave, they undergo refraction and reflection inside the Earth. Okay? Refraction simply means diffusion, right? Outward movement of the seismic wave, right? In simple terms, I would say. And reflection means rebound pattern of movement inward, right? Rebound pattern of movement of seismic wave is reflection. There are different types of reflection inside the Earth. Simple reflection, twin reflection. There are different types of reflection. We'll talk about that. So this is your travel path, right? Travel path taken by the seismic wave. So based on the observation of their velocity and their travel path, right? The travel path we try to scan the Earth interior. Okay, right? So let us now talk about this seismic wave. What are those seismic waves? Okay. So in simple terms, you can say that seismic waves are nothing but energy waves. Okay, energy waves. And these energy waves are released the moment you have disturbance in the crust, right? The moment you have the rocks being subjected to disequilibrium. That means if the rocks are subjected to compression, fracturing, crushing, faulting, anything, right? So if the rocks are disturbed inside the earth, what will happen? The energy which is preserved in the rock, the energy which is stored in the rock, that energy would be released, right? That energy would be released. That energy travels in all directions, and that energy is recorded by those instruments we place on the surface of Earth at different locations, and especially those instruments are placed at those locations where seismic events are more frequent, right? More common. So these are your seismic waves, right? Or you can say energy waves. Those energy waves are the heat stored in the rocks. Once the rocks are in stable position, right? You know that Earth interior has different source of heat, right? One of the major source of heat inside the Earth is radioactive material, right? 50% of the heat generated by Earth interior comes from radioactive decay. Okay. Second heat is your residual heat. That means when the Earth evolved from a gaseous nebula to a solid body, it underwent compression, and compression led to increase in density. Increase in density led to what? Concentration of heat inside the Earth. We call this as residual heat. Okay. I said we call it as residual heat. So these are your two important source of heat inside the Earth. Especially in the upper part of the Earth interior, you will find the radioactive material which are highly concentrated. You will find 98% of radioactive material in upper mantle, and that leads to spontaneous release of energy. Now that energy is being released inside the Earth, and that energy would be the energy would be stored where? Obviously, the energy would be stored in those minerals which are aggregating together to develop into rocks, right? They are in solid state, and they are being heated up by the energy released by radioactive decay. That energy is preserved within the body of the rocks, right? And they remain in equilibrium unless until they are subjected to what? Unless until they are subjected to fracturing, and that fracturing can happen That fracturing can happen because of two regions. One is the common region, we call it as plate tectonics, right? When you have the plates in motion, what will happen? The rocks would be subjected to crushing, right? When two plates are colliding with each other, the rocks would be subjected to crushing. The rock will undergo fracturing, and once the rock undergo fracturing, what happens? The energy which is preserved in the body of the rock, that would be released, right? We call such energy release as tremor or shaking of the earth crust, right? Shaking of the earth crust. So this is your seismic wave, which are nothing but the energy which is preserved in the rock. Once the rocks are subjected to alteration, once those rocks are subjected to disturbance, once those rocks are subjected to faulting, faulting is breakage, right? Once the rocks are subjected to crushing, any of those processes, any of such deformation activity will lead to what? Will lead to breakage in the rock, and the energy which is stored in the rock, that would be quickly released, right? That energy reaches the surface, and that produces what? That produces tremor, right? That produces shaking of the earth surface. So that is your seismic waves. Okay. Now just take one example. You have this rock structure. Fine. Now this rock structure is subjected to two kind of force. One is your compressional force, the other is tensional force, right? These are the only two kinds of force you find, because you know that you have two kinds of movement taking place on the surface of Earth, that is above the astrosphere, that is divergent movement and convergent movement. So two kinds of forces are operating. One is your compressional force, and the other is your tensional force. That means the forces which are acting towards the body, and the other force which is acting away from the body, right? Away from the body. Now what happens? When the compressional forces are acting upon the body of the rock have multiple joints. The rocks have multiple joints, and if this rock is an elastic rock, let us assume that this is an igneous rock, okay? Elastic rock, okay? It is rigid as well as elastic. That means it can be compressed. That means it can absorb the shock, and it can also release the shock, okay? So this is your igneous rock, which is subjected to compressional force. If the force applied on the rock is greater than the elasticity of the rock, right? That means the tensile strength of the rock. What is going to happen? The rock is going to break down. The rock is going to break down along what? Along the line of weakness in the rock that is called as fault line, right? And that activity is called as faulting. Once the rock undergoes faulting along this fault line, what will happen? This zone becomes the zone from where the seismic waves or energy waves have been released. Okay, energy waves have been released. That means these two blocks have been subjected to displacement, right? They are just being broken down now, right? They have been deformed now. Okay. Likewise, if I take this as a fault line here, and this rock block is subjected to tensional force, what will happen? Again, this rock is going to break down along this line of weakness, and that will lead to what? Again, that will lead to release of energy. So this zone again becomes the zone from where energy waves are released. Okay. So this is your activity, we call it as, in simple terms I would say it is called as deformation of rock. बस टर्म पे फोकस करना है, formation and deformation, right? Okay, deformation, that means breakage in the rock, that means displacement in the rock. And once those rocks are displaced, the energy which is preserved in the rock, why the energy is preserved in the rock? Now you see this one. You'll find that Earth more or less behaves as a closed system. This is your lithosphere. And this lithosphere is this lithosphere is fractured into many major and minor blocks. Those major and minor blocks are your major and minor plates, right? These major and minor plates are gliding over astrosphere and they are moving in two different directions, either away from each other or they are moving towards each other. ठीक है, यही होता है लिथोस्फीयर, है ना? अब क्या होने वाला है? When this lithosphere does not provide any ready-made opening, right? Ready-made opening नहीं है. That means when you have two lithospheric blocks moving towards each other, what happens? One of the block which is denser subduct under the lighter one. Yes. Let us assume that this is the denser one. Okay, it subducts. So in this case, what is happening here? The Earth is behaving as a closed system. Right? Closed system means what? Now the load of that super incumbent material. That means the overhead material. You have materials lying inside the Earth. Okay, those materials are behaving in solid state. Even though we have even then when we have very high temperature inside the Earth, the material is behaving in solid state. Why? The material is behaving in solid state because the Earth is behaving as a closed system, right? There is no ready-made opening here. So ultimately, the pressure which is exerted by the superincumbent load, that means the lithosphere above, the pressure which is exerted by the superincumbent load upon the underlying rock. You have rock here. So what happens to these rocks? These rocks are in solid state. They behave in solid state. Why? Because these rocks are subjected to superincumbent load, the superincumbent pressure. Now, application of superincumbent load upon the underlying material will lead to what? Will lead to the increase in the density of this material. Density increases, right? When the density increases, ultimately what happens? Then melting point increases. When that melting point increases, what will happen to these materials? These materials will remain in solid state, though we have very high temperature here, maybe 1200 degrees Celsius of temperature, right? But they are not, right? They are not converting into liquid state. Why? Because the pressure of the material lying above is keeping that underlying material in solid state by countering high temperature, and that high temperature is countered by raising their melting point. Okay? So in this case, the rock will remain in solid state. Okay, when the Earth is behaving as a closed system. But the moment the Earth behaves as an open system, there are some zones where you have Earth behaving as an open system, where you have divergent plate movement taking place, right? Plates moving in opposite direction. Okay, tensional forces, right? So when you have the plates moving in opposite direction, what happened to the underlying material now? What will happen to the solid material now? Once this plate has, say, once the plate has split, okay? Once the plate has split, once the plate has, right, has started moving in opposite direction, now this, right, now this zone has become what? This zone has become, or now it will behave as a open system. So one thing you should keep in mind that Earth more or less behaves as a closed system, right? That is why we have effective, right, effective existence of superincumbent load. We'll talk about that in detail later on. That is your pressure, right? Pressure of that overlying layer. देखो ना ऊपर क्या है, rocks है और नीचे भी material है. नीचे कौन सा material है? Obviously rocks, right? Those rocks are in solid state. Why? This is the question. Those rocks are in solid state, right? They are in solid state. Why? Because the load of that overlying layer is compressing those material and they witness an increase in density, right? Increase in density ultimately raises their melting point. Melting point is what? The temperature at which any particular rock or mineral will melt down, right? So their melting point goes up. Though we have very high temperature here, but still they are in solid state. So no, they are in solid state. Why? Because the superincumbent load is able to keep them in solid state, that is countering high temperature inside the earth. Okay? But in open system, what happens? The moment you have split, the moment you have split, what will happen to the superincumbent load? What will happen to the pressure, my friend? The superincumbent load or the pressure becomes ineffective now, right? Now it has become an open system and pressure will be automatically released, right? Once that pressure is released, what will happen to the underlying material? The underlying material will quickly respond to high temperature condition, that is 1200 degrees Celsius, and they will convert from solid to what? Liquid. And this liquid material will proceed toward the surface in the form of superheated material, that is magma, and the magma will come out and will get deposited, right? Yes or no? This is right. This is how I said. This is how the energy waves, right? Energy waves are generated. Either we have a closed system or we have a open system. In the case of open system, I said you have temperature becoming effective because the temperature is not being counterbalanced by the superincumbent load because the plate is moving away from each other, right? And ultimately, the pressure exerted by overlying layer is becoming ineffective, right? There is no pressure now. There is no pressure of that overlying layer, and ultimately the underlying material they succumb to high temperature condition and they convert from solid to the liquid state. That is your superheated magma, and the magma proceed toward the surface. That is why wherever we have open system, the magma comes out regularly, right? There is continuous eruption of magma. ठीक है, जहाँ भी divergent boundary होगा, ठीक है? Wherever you have divergent boundary, what do you find? The magma comes out continuously, right? It comes out gradually, continuously, slow eruption goes on throughout the time period. That means in the entire history of Earth, right? Even today that is going, right? That is happening, right? Every day, okay? The magma is coming out, right? It is coming out gradually and there is continuous eruption. But in this case, that means in the case of closed system, what will happen? When this plate will further subduct, what will happen to this plate? What will happen to this plate? This plate will subduct and it will go deep inside the earth. It will have friction with the rock, and high temperature is found here. Ultimately, what happens? The subducted lithospheric block undergoes melting, right? Melting. अब जब उसका melting होगा तो क्या होगा? There will be accumulation of magma, right? This magma which is developed here is becoming violent. Why it is becoming violent? Because there is no natural opening on the crust, right? There is no natural opening on the crust. Along with the subduction of the plate here, you have large amount of water also. Let us assume that this is an oceanic plate, right? And you have large amount of water also getting inside the earth, okay? That water converts into what? As the water seeps into the deeper part of the earth, what will happen? The water will be heated up, right? And the water will convert from, the water will convert from liquid state to the gaseous state. That is your water vapor and steam, right? Water vapor and steam will mix with the magma here, and that will expand the magma, right? That will lead to expansion in the magma. Now the magma becomes violent and it is not going to stay here. It keeps on hitting the crust above. Keeps on hitting the crust.
right? It melts the crust, again hits the crust, again melts the crust, hit the crust, like this. Okay, so it is regularly hitting the crust, and maybe after billions and millions of years, it is right. It is able to what? It is able to right. It is able to pierce through the crust and comes out violently on the surface of Earth in the form of those violent volcanic eruptions, right? Giving rise to those those volcanic cones, right, which we have in the world. Like you talk about Japanese archipelago, you can talk about Indonesian archipelago, Philippine archipelago. These all islands have evolved, have evolved in this manner, right? So this is your activity we see, we see in the case of closed system, ठीक है? तो ध्यान रखना है कि more or less जो हमारा अर्थ है वो कैसा है? It is behaving as a closed system, more or less, right? But there are some zones where you have splitting plate boundary and divergent movement, or the lithospheric plate movement in opposite direction is making the Earth system open, and ultimately the pressure is released and the underlying material undergoes melting. Okay, undergoes melting. So even sudden eruption of magma that can lead to what? That can lead to shock on the rocks. The rocks are being hit by the magma. Okay, and that will lead to what? Again displacement, and maybe you can have tremor here also, right? Okay, but keep in mind the tremor can happen only when you have crustal fracturing, crustal disturbance, crustal breakdown, right? That means the breakage of the rocks. Simple, right? Breakage of the rock. Once you have the rocks being subjected to deformation, they release the energy, and that energy would be recorded by the instruments. Okay. So now you know how this energy is released, from where that energy is coming, what is the source of that energy. So I took this example here just to highlight one point here. How that energy stored inside the Earth is being released, and that leads to tremor, that leads to shaking on the surface of Earth. Now this seismic wave or energy waves are of two types: body waves and surface waves. Body waves and surface waves. Body waves again are of two types: primary waves, or also called as P waves, and secondary wave, also called as S waves. Surface wave, they are called as long waves because of their wave height. We call it as amplitude, right? The amplitude of such wave is very high, so they are called as long wave, and they are of two types. One is love wave and the other is relief wave. Fine. So let us see one diagram here to understand what happens when we have the rocks, rocks subjected to deformation, right? When the rocks are subjected to deformation, I said they experience a zone along which the displacement breakage take place, right? And the zone where the displacement or breakage is taking place, that would be the zone from where the energy would be released. Yes or no? Right? That zone from where the energy is released, that is stored in the rock, that point or that zone is called as, क्या बोलते हैं उसको? That point is called as focus, or we also call it as hypocenter, right? Hypocenter. So focus is what? Focus is the point or zone from where the energy waves are released. Okay? See, again, don't get confused. I am taking focus here at a relatively greater depth, right? So that I am able to show the body wave, that is your P and S wave, more clearly. Actually, the depth up to which focus can be seen inside the Earth is only 700 kilometers. Beyond 700 kilometers, we do not have any location of focus, right? ठीक है, तो अल्टीमेट डेप्थ जो है जहां तक हमको आज तक सिस्मिक फोकस मिला है वो कहां है? दैट इज 700 किलोमीटर. ठीक है, तो मैं जब यहाँ पे फोकस बना रहा हूँ तो आप इसको कंफ्यूज मत करना, क्योंकि ये अर्थ है ना, और यहाँ फोकस का मतलब मैं सेंटर के आसपास हूँ. ठीक है ना, बात समझ में आ रहा है? तो I'm taking greater depth of the focus with a region. तो याद रखना फोकस का मैक्सिमम डेप्थ कितना हो सकता है? 700 किलोमीटर, not more than that, right? Now you have crustal deformation here, right? The rocks have been subjected to deformation, the rocks have been subjected to faulting, and that energy is released, and that energy travels in all direction. It travels in all direction. That means toward the earth interior, उल्टे साइड में भी, ठीक है? Toward the earth interior and toward the surface of the earth. Toward the earth interior and towards the surface of the earth. Okay. So I'm just removing this so that we are focused on one zone. ठीक है? चारों तरफ जाएंगे, ठीक है? They travel in all directions. And this seismic wave would be recorded first, Recorded first where? At a point that is called as epicenter on the surface of Earth, right? So the point which lies, the point which lies perpendicularly above the focus, above the focus on the surface of Earth is called as epicenter, because this is the point, this is the zone, this is the location where seismic waves are recorded first. सबसे पहले एपीसेंटर में ही seismic waves का क्या करते हैं, उनको रिकॉर्ड किया जाता है, right? They arrive at epicenter, right? They arrive at epicenter first. That is your point where seismic waves are recorded first. ठीक है? सबसे पहले वहां पहुंचते हैं. And this is right. The seismic waves, I said, the seismic waves are of two types. I told you PS. You have PS, right? PS. So these are your body waves. ठीक है ना? Right? So there are two types. Now P waves, right? P waves generally during earthquake, what happens? It is your P wave generally which arrives at the surface. Why I'm saying generally? Because when we talk about the land area, obviously P wave would be the first wave to arrive at the epicenter, right? That would be the first wave to be recorded at the epicenter. Okay, but that is not true about the water surface. ठीक है? आपको मालूम है पानी के अंदर भी प्लेट मूवमेंट हो रहा है, right? And that leads to what? Ocean convergence. We'll talk about that. In the case of ocean convergence, what happens? Again, you have seismic foci generated, right? Again, that leads to release of energy. But in this case, you know that only P, only P wave would be recorded at the surface, because P waves are able to pass through all three states of matter, right? Whereas S wave can pass only through solid. That is why in the case of tsunami का तो सुना होगा आपने. Tsunami के केस में क्या होता है? You have no S waves recorded, right? You find only P wave. Okay. तो water surface पे जो wave record होगा वो कौन सा होगा? That would be P wave, not the S waves, right? Both the waves would be released, but S wave would not be recorded. Okay. That is why I am saying generally you'll find P wave, being recorded first here. Why? Because P waves are faster than S waves. ठीक है? P waves से faster होते हैं, इसलिए यहाँ पे रिकॉर्ड हो जाएगा. ठीक है? Now once those body waves strike the surface of Earth, they activate another set of waves which remain at the surface of the Earth only, and such waves are called as surface wave. ठीक है? ये surface पे ही रहते हैं. मतलब they have horizontal motion. Right? They have horizontal. When I say horizontal motion, I'm not saying that the wave particles will have horizontal motion in both the cases, love and relic wave. ठीक है? दोनों में अलग-अलग हो जाता है. But they graze the surface of Earth only, right? They remain at the surface of Earth only. They remain near the surface of Earth. They do not get inside. ठीक है? अंदर नहीं जाते. ठीक है? So when those surface waves are not getting inside the Earth, it means that the surface wave cannot tell us anything about the Earth interior. ठीक है? We are interested in studying Earth interior, not the earthquakes. Yes or no? Right? We are interested in knowing the Earth interior, and all such information come from the body wave, not from the surface wave, because the surface wave remain at the surface of Earth only, and they do not get inside. This surface wave also do not have sui generis. That means That means these waves cannot be activated by themselves, cannot activate by themselves. ओके, खुद से नहीं वो एक्टिवेट होते, ठीक है। जब तक कि बॉडी वेव स्ट्राइक नहीं करेंगे तब तक कि सरफेस वेव का क्या होगा, सरफेस वेव्स विल नॉट कम इनटू राइट, विल नॉट कम इनटू एग्जिस्टेंस, राइट, ठीक है। तो सरफेस वेव डू नॉट हैव sui generis, they have right, they have, I said, they have their life dependent on the body wave, right? Body wave will strike the surface and that will lead to the activation of another set of wave. I said that is your surface wave, which remain close to the surface of Earth, which remain near to the surface of Earth. It does not get inside the Earth. Okay? This is your surface wave. Fine. So now you know, right? Now you know. Now you know the body waves and surface wave. I'm not talking about their impact. I'm not talking about talking about those waves in saying in terms of, I said, in terms of magnitude and intensity, because these things we'll discuss in earthquake. ठीक है? तो यहाँ पे बस हम लोग उसका इस्तेमाल करने वाले हैं. We'll be just using the properties of body waves to understand the earth interior. So first thing, we'll talk about the body waves. I told you very clearly that surface waves are of no importance to us, especially in the study of earth interior. Okay, they do not tell us anything about earth interior, so we are not going to focus here much. ठीक है, हम लोगों को क्या ध्यान रखना है? Though I'll talk about this surface wave because I don't want to repeat this topic again in earthquake. So when I talk about earthquake, I can directly deal with why and how part of earthquake. I can avoid talking about seismic waves. ठीक है? So this is your this is the plan we are going to follow. So first of all, let us talk about the body waves and see how P and S wave behave. ठीक है? So first of all, P waves, primary waves. Now what are the characteristics of primary waves? क्या characteristics है? These primary waves are longitudinal waves. Longitudinal waves. Fine. These are longitudinal waves, right? That means these waves, I said, these waves have shorter amplitude and relatively longer wavelength. Wavelength समझते हैं ना? ये अगर ये मान लो wave है, if this is your wave, right? So this will be called as wavelength. ये हमारा wavelength हो जाएगा, यहाँ से यहाँ तक, है ना? And this rise and fall, the wavy action of wave, ठीक है? Rise and fall, oscillatory motion of the wave, that is in the form of crest and trough, that is called as wave height, right? Wave height, मतलब ये हमारा wave height हो जाएगा, ठीक है? That would be your wave height, ठीक है? In the form of crest and trough, like this, crest and trough. So this is your difference between wave length and amplitude, right? Wave height, जिसको simple terms में wave height बोल सकते हो, ठीक है? दोनों में एक और भी रिलेशन होता है, जैसे आपको पता है कि the shorter the wavelength, right? Shorter the wavelength will have high frequency of the wave, ठीक है? And vice versa, ठीक है? अगर long wave होंगे तो उसका frequency कम हो जाएगा, ठीक है? बात समझ में आ रहा है? ये सब बेसिक चीज है जो आपको पता है और हम लोग डिस्कस भी करते रहेंगे इसको. तो this is your primary waves, which are longitudinal waves, and these waves they move in to and fro motion, or you can say in push-pull manner, right? तो कैसे चलते हैं ये? push pull, right? So in these waves, that means in primary waves, you will find the wave particles moving in push pull manner or to and fro manner, right? In to and fro manner. Okay. This is your manner in which the wave particles move or travel within the primary waves. So if I take this as the direction of propagation of wave, that means अगर wave का direction ये है चलने का, ठीक है? तो wave particles कैसे चलते हैं? These are your wave particles, and these wave particles they move in, right, they move in which manner? कैसे चलेंगे? These wave particles will move in to and fro motion. That means compression, expansion, compression, expansion, compression, expansion, push pull, push pull. देखो क्या हो रहा है? ये wave particle क्या हो रहा है यहाँ पे? देख सकते हो आप? यह right, क्या हो रहा है ये? अरे क्या हो रहा है? Push, yes or no? And then right, then you have pull, push, pull, push, pull, like this. Okay. So this is your push-pull manner in which the wave particles, right, wave particle move, and that is why when the P waves pass through a rock structure, क्या करते हैं? When P waves pass through a rock structure, they subject the rock to compression and expansion. ठीक है? तो I'm just showing this this P wave in a rock structure. अगर मान लो ये rock structure से होते हुए जाए तो कैसा काम करेगा? किस तरह से travel करने वाला है? So these P waves will travel, right? They will enter into the rocks, right? And they will what? They will subject the rock to compression and then expansion. Compression, expansion. Compression, expansion. Compression, expansion. So this is your this is your compression. That means simple terms में इसको हम stress बोलते हैं, stress, right? And this is your expansion. That means strain. So the rocks are subjected to what? The rocks are subjected to stress and strain. Okay? Compress and expand. Compress, expand. Compress, expand, like this. Okay? So what will happen if the rocks are of different type? If say if the P waves are passing through two different types of rock. ठीक है, ध्यान से सुनना है. अगर P wave मान लो दो अलग-अलग रॉक की तरफ से दो अलग-अलग रॉक में पास कर रहे हैं, ठीक है? मालूम है we have three types of rock: igneous, right, sedimentary and metamorphic, right? Igneous and metamorphic both are elastic rocks, ठीक है? They are compressible rock, right? They are relatively more flexible, है ना? Rigid भी होते हैं और flexible भी होते हैं. ठीक है, so they are elastic rock. That means they have high tensile strength. They can bear the force, right? They can undergo compression, and they can also adjust with expansion, right? They are more flexible. Whereas sedimentary rocks are they are fragile rock, they are weak rock, okay? And when the seismic wave pass through the sedimentary layer, what will happen to the sedimentary layer? Obviously, that will be subjected to compression, expansion, and that will tear apart the rocks, right? The rocks will start breaking down, and that is the reason why you must have heard about those incidents. Like whenever we have earthquake in Himalaya, especially in middle Himalaya, inner Himalaya, whenever you have those epicenter, I'm talking about those mild earthquake. I'm not talking about the earthquake having very high magnitude, right? When you have mild earthquake, right, maybe the magnitude ranging between 4.5, 5. So what happens? You have the mountainous area, right? Mountainous area representing no damage in life and property. That means there is no intensity felt, right? ठीक है, intensity नहीं है, मतलब the degree of damage and destruction in middle Himalaya, inner Himalaya remains very low, right? पहला रीजन तो समझ में आता है because you have low concentration of population, so that is understood, right? But there is no damage to the property भी damage नहीं हो रहा है, right? Why? Because both inner and middle Himalaya are made up of elastic rock, that is igneous rock, right? And whenever you have shock passing through, that means the energy wave passing through the rocks are able to absorb, and again they come to equilibrium after the energy has passed through the body, right? That is why they do not undergo fracturing, right? Displacement नहीं होता. But shock there, epicenter there in Himalayan belt gives maximum shock where? It gives maximum shock in Shivalik belt. It gives maximum shock in Great Indian Plain. Yes, why? Because the Shivalik and Great Indian Plain both are made up of sedimentary material. And in fact, what? We have earthquake there in middle Himalaya, but the houses have been gutted down where? In Bihar, UP, Haryana, Punjab. Why? Because this is the belt which is having what? Which is having sedimentary layer. ठीक है? तो इसका जो शॉक होगा अलग अलग स्ट्रक्चर पे अलग अलग होगा, ठीक है? अगर इलास्टिक स्ट्रक्चर है मतलब इग्नियस मेटामॉर्फिक है तो डैमेज थोड़ा कम होगा, ठीक है? अब इसको एक और एंगल से देखना है, जो मैंने क्या बोला, व्हाट इज द अमाउंट ऑफ एनर्जी रिलीज ड्यूरिंग द अर्थक्वेक, राइट? ठीक है, अगर मान लो मैग्नीट्यूड माइल्ड है, ठीक है, इफ यू हैव माइल्ड अर्थक्वेक मैग्नीट्यूड बिटवीन 4 5 3 4 लाइक दिस, ठीक है, तो आपको कुछ वहां पे नहीं होता है। लेकिन इफ यू हैव मैग्नीट्यूड वेरी हाई, व्हाट विल हैपन देन? मान लो बहुत ज्यादा मैग्नीट्यूड है, जो छोटा एक एग्जांपल मैं देता हूं आपको। यू रिमेंबर दैट काठमांडू अर्थक्वेक इन 2016, ठीक है, काठमांडू अर्थक्वेक आया तो व्हाट वाज द मैग्नीट्यूड? द मैग्नीट्यूड ऑफ द अर्थक्वेक वाज अराउंड 8.4, ठीक है, 8.4 था, बहुत हाई होता है, ठीक है। जो हाईएस्ट मैग्नीट्यूड आज तक दुनिया में रिकॉर्ड किया गया दैट इज 9.3, राइट, दैट इज ड्यूरिंग सुनामी इन जापान इन द ईयर 2011, ठीक है। और जो काठमांडू में अर्थक्वेक आया वो 8.4। काठमांडू कहाँ है? दैट इज इन मिडिल हिमालय, यस। So Kathmandu is having what? The Kathmandu city is having a base rock which is made up of elastic material, that is igneous rock, ठीक है। तो प्रैक्टिकली वहां पे डैमेज डिस्ट्रक्शन नहीं होना चाहिए था, ठीक है, बट we had high degree of damage and destruction. Why? Because elastic rock too break down. They too can break down when the force or energy applied on the rock is higher than their tensile strength, right? It's not that those rocks will not break down, but they will not easily break down. Are you getting my point? Right? They too break down, but that rock is resistant to such forces to some degree, and once the magnitude of the force increases, those rocks too undergo breaking, right? And that leads to maximum damage and destruction. ठीक है? तो इसलिए मैंने आपको ये बताया क्योंकि आगे चल के सारा कुछ हम लोग को बात करना है। Once we come onto the surface of Earth, we'll understand how the processes operate. Okay. So this is your behavior of primary waves. Now these primary waves can pass through solid, liquid and gases alike. ठीक है? P wave जो है तीनों मीडियम से पास कर सकते हैं, solid, liquid और gas. But they are fastest recorded where? They are fastest in solid. Fastest in solid. Right? ठीक है? Which means what? If the substance or the structure through which the wave is passing, और जब मैं substance structure बोलता हूँ आपको बस rocks को समझना है, ठीक है? ठीक है? I'm not using those terms repeatedly because we have not studied the rocks. Okay? The next topic after this would be rocks only. Okay, so this is your primary waves which are able to pass through all state of matter, but they are fastest recorded in solid, which means that if the rigidity of the substance is higher, rigidity and compressibility, right, rigidity and compressibility, right. So if the rigidity of the substance is higher, compressibility of the substance is higher, higher would be the velocity of P waves, ठीक है। P waves उतना ही फास्ट होंगे। अच्छा, रिजिडिटी है क्या? छोटा छोटा बात है लेकिन बाद में बहुत हॉन्ट करता है। रिजिडिटी मतलब सिंपल होता है स्टिफनेस, ठीक है, which is just opposite to compressibility. Compressibility means what? Flexibility. ठीक है। अब आपको पता है कि इग्नियस रॉक, मेटामॉर्फिक रॉक कैसे होते हैं? रिजिड रॉक्स हैं, स्टिफ है, ठीक है। दे आर रेजिस्टेंट टू व्हाट? दे आर रेजिस्टेंट टू इरोजन, दे कैन नॉट बी इरोडेड फास्टली, ठीक है। पर सेडिमेंट्री रॉक तुरंत इरोड हो जाते हैं। क्यों? बिकॉज the bond, right, the molecular bond within the sedimentary rock is weak, whereas in the case of igneous and metamorphic rock you will find strong bond between the molecules of the rock, and that is why we have no intermolecular gap, right. There is no intermolecular space, and that is why you have stiffness in the rock, ठीक है, right. स्टिफ भी है और साथ साथ में कैसा है? बिकॉज ऑफ द मटेरियल कंटेंट। किससे बना है इग्नियस? अरे किससे बना है इग्नियस रॉक्स? इग्नियस रॉक्स आर मेड अप ऑफ व्हाट? दे आर मेड अप ऑफ एसिडिक मैग्मा, जिसमें कि सिलिका ज्यादा है, जिसमें कि मैग्नीशियम है, राइट, एंड सम प्रोपोर्शन ऑफ आयरन आल्सो, ठीक है। So they are right, they are flexible, right? They are flexible also. That means they can be compressed. जो मैंने अभी ये बताया, ठीक है? They can be compressed to some degree and they can also be expanded to some degree. That means they are flexible, right? Flexible. So higher the flexibility, higher the stiffness of the substance, higher will be the velocity of P wave. Okay, and that is applicable to right S wave also. The only difference is what? In the case of S wave, compressibility would be replaced by hardness. That means if the substance is rigid as well as hard, right? As well as hard. If it is hard, right? Hard and rigid, then in that case, right? Then in that case, the velocity of S wave would be higher. ठीक है? अब बोलेंगे आप हार्डनेस और रिजिडिटी में क्या अंतर है? ठीक है? तो मैंने बोला रिजिडिटी क्या है? स्टिफनेस, राइट? और हार्डनेस क्या है? हार्डनेस इज द डिग्री ऑफ रेजिस्टेंस द रॉक ऑफर्स टू व्हाट? ऑफर्स टू वेदरिंग एंड इरोजन. ठीक है? वेदरिंग एंड इरोजन. बहुत फाइन लाइन का डिफरेंस है यहाँ पे. स्टिफनेस मैंने क्या बोला? स्टिफनेस इज द मॉलिक्यूलर बॉन्ड, right? If the bonding between the molecules are very strong, there is no or minimum, right? Minimum intermolecular space, then we can say that the substance is rigid. Okay? Hardness is what? Hardness is resistance, right? What is the degree of resistance to erosion, right? Whether you are easily eroded or so it takes time for the exogenetic process to erode, right? Erode you. That means the rocks. Okay? That is called as hardness. Okay, so in case of S wave, the only difference would be hardness. Okay, not compressibility. Fine. So this is the behavior of primary wave. One more thing you should keep in mind that they are faster than S wave. S wave से faster होते हैं. Faster than S waves, and that is 1.7 times. Right. They are 1.7 times faster than the S waves. ठीक है? बात समझ में आ रहा है? तो इससे क्या समझ में आता है आपको एक बात जो सिंपल समझना है. When we see the P and S wave, that means the body waves, right? As they proceed from or as they proceed near to the surface toward the earth interior, what will happen to their velocity? Generally their velocity should increase. So no. Why? Because we know that as we go towards the earth interior, the density of the substance is increasing, right? The rigidity of the substance is increasing, right? You will find more and more stiffness in the substance, and ultimately the velocity should have an increasing trend, right? But they do not have uniform high velocity inside the velocity of the seismic wave changes because of the material distribution inside the earth, because of the nature of material found at different depth of earth interior. ठीक है? So we'll talk about that. But अगर ऐसा होता कि अर्थ होमोजीनियस होता तो क्या होते? सिस्मिक वेव बिल्कुल स्ट्रेट पाथ में चलते, ठीक है? यहाँ से चलते और वहां पे रिकॉर्ड हो जाते, ठीक है ना? पर स्ट्रेट पाथ में नहीं जाते, इसका मतलब कि अंदर कुछ और चल रहा है, ठीक है? We do not have uniform distribution of material inside the earth. Okay. So one thing is generally accepted that yes, we have an increasing trend of density inside the earth, right? Increasing trend. And if the density increases, what will happen to the velocity of seismic wave? That means body wave. What will happen to the velocity? Obviously, the velocity should have a increasing trend, right? Right? But that is only one aspect of the story. We'll talk about the second aspect just after this. So this is your primary wave. Then these primary waves are similar to your sound waves. जैसे sound wave होते हैं उसी तरह से आपको, ठीक है, उसी तरह के primary waves हमको दिखते हैं, ठीक है ना? Sound wave मतलब they have properties similar to sound wave, right? Just like you hit a metal, अगर किसी metal को आप hit करते हो, ठीक है, जो sound जो vibration आप सुनाई देता है वो क्या है? It is just like your P waves, right? So they have similar property as of the sound wave. Fine. So these are your points you have to keep in mind. Just 2 points here. Okay? I mean, especially in the context of scanning this earth interior, we take into account 2 points here. One, they can pass through all 3 states of matter. And number 2, they are fastest recorded in solid. Number 3, they are faster than S waves. बस इतना ही बात आपको याद रखना है, ठीक है? secondary waves or S waves. These secondary wave or S wave are also called as longitudinal waves. Sorry. They are called as transversal wave or distortional wave. Distortional. And the wave particles within the secondary wave, they move right angles to the direction of propagation of wave. That means in this manner. If this is the direction of propagation of wave, then you will find the wave particles moving in right angle. They move right angle to the direction of propagation of wave in the form of crest and trough. So this is your wave particle. You will find wave particle moving right angle to the direction of propagation of wave. These dots I am highlighting here to to represent those wave particles. They move right angle, है ना? Right angle to the direction of propagation of wave. तो अगर ये rock होगा, मान लो ये rock है, and if the S wave is passing through this, what will happen to the rock? The rock would be subjected to vertical displacement. कैसे? Waves could be created on the rocks like this. Vertical displacement. You will find vertical displacement in the rock. Okay? And they are in the form of crest and trough. Crest, ये crest हो गया, and this is your trough, right? ठीक है, तो wave particles कैसे चलते हैं? Right angle to the direction of propagation of wave. ठीक है? And that is the reason why when S wave arrive at epicenter, that is the time when we get maximum shaking. ठीक है? Why? Because P waves they just compress and they compress and expand. Compress and expand the rocks, and that is either horizontally or vertically. दोनों हो सकता है, right? इधर देखो ये जो मैंने लिखा है ऐसे भी हो सकता है, compression expansion. मतलब vertical extension or vertical displacement would be minimum because the wave is pulling the rock and then pushing the rock, pushing the rock like this. Okay. But when S wave arrive, what happens? That is the time when we get main shock. ठीक है? देखा होगा आपने earthquake आता है तो generally क्या होता है? Pre-shock. We find mild shaking, and then after few seconds you'll find main shock. Right? You'll find more shaking. So more shaking is mainly because of the vertical displacement, right? The S wave only do vertical displacement, rise, fall, right? So this is your manner in which the S wave travel. This S wave can pass only through solid. ये हमको point याद रखना है. They can pass only through solids, right? Not liquid or gas, fine? Only through solid. इनका प्रॉपर्टी क्या है? ये सिर्फ सॉलिड मटेरियल में, सॉलिड मीडियम में ही चल सकते हैं. ठीक है? These S waves are just like your light waves. जैसे light waves होते हैं हमारे, right? They are having similar property as of those light waves. ठीक है? So these are the points you have to keep in mind. Just 2 points here. ठीक है? Number one, they are distortional wave, right? The wave particles move in up and down manner. That is your right angle to the direction of propagation of wave, and they can pass only through solid. ठीक है? सिर्फ solid से pass कर सकते हैं और दूसरे medium से नहीं. ठीक है? ये बात हमको ध्यान रखना है. Now quickly see the surface waves also. As I said, surface waves have no importance in the study of Earth interior, but still we'll complete this because we don't have to repeat it again. So surface waves are also called as long waves because of their higher amplitude, right? Like if you compare these waves, जैसे ये मान लो P wave है, तो P wave कैसा होगा? This is your P wave, and then you will find S wave, and then you will find the surface wave. The highest amplitude is seen for इसको highest amplitude we have for the surface wave. The only difference is that the surface wave are grazing the surface of the earth only. They are not entering inside the earth. Okay? Main difference is okay? And that is the reason why they cause maximum damage and destruction to life and property, because they are responsible for maximum vertical displacement, right? Amplitude of the wave is very high. Okay? So it is actually the surface waves which are responsible for high intensity during an earthquake. Okay? है ना? सबसे ज्यादा intensity क्या होता है? Degree of damage and destruction, right? So degree of damage and destruction is mainly controlled by the surface wave because they have higher amplitude. Now these waves are covering the surface of the earth, so obviously they would be covering the largest part of the earth's surface, right? Okay, the wave which covers largest part of the earth's surface, I'm talking about the earth's surface, not the earth interior, right? So they cover largest part of the earth's surface in comparison to the body waves, right? Body waves, what they do? Body waves are striking the surface of the earth, right? Striking the surface of earth. Some of the waves are being reflected back, right? Then again these waves travel toward the surface. We call it as what? We call it as क्या बोलते हैं? We call it as twin reflection. ठीक है? Body wave ने पहले surface को hit किया, and then it rebound back, right? And again it is being reflected towards the earth's surface, right? So this is how the body waves are playing. They are within the earth interior only. ठीक है? Earth के अंदर में. लेकिन जो surface wave क्या है? They are near to the surface. They are grazing the surface. That is why they cover the largest area on the surface of earth, right? Okay. So this is your surface wave. Now there are two types: love and railing wave. ठीक है? Love wave में क्या होता है? What is the pattern of movement of the love wave? Keep in mind both are your surface wave. They would be moving at the surface only, right? So in the case of love wave, you'll find the wave particle moving in what? Moving in sideways, left, right, just like meandering of a river. ठीक है? Zigzag pattern. ठीक है? कभी right, फिर कभी left, फिर right, कभी left. ठीक है? एक काम करना है. You see your study material page number 22-23. You have a diagram there. Yes, this one. तो मैंने आपको 4 डायग्राम वहां पे दिया हुआ है, आप देख सकते हो. डायग्राम जो पहला डायग्राम है A, that is representing P wave. B, you can see that is your S wave, right? Secondary wave. टॉप कॉर्नर में पेज नंबर देखना है. मैंने पहले दिन रूल बताया था कि स्टडी मटेरियल को कैसे देखना है. टॉप कॉर्नर में देखिए. विजिबल नहीं है, नॉट विजिबल. ओके, जस्ट गिव मी दिस वन. ये पेज है, जस्ट गिव दिस वन है. तो आप लोगों ने स्टडी मटेरियल मतलब बस घर में रखा हुआ है, देखा नहीं है कभी कौन सा पेज कहाँ पे. कम से कम जो टॉपिक होने वाला उसको तो देख लीजिए. हाँ, एक रीडिंग तो करके आइए. किस इंतजार में आप लोग? किस इंतजार में? मतलब कोई मैं बाबा हुआ हूँ क्या आपको जो मंत्र पढ़ के दूंगा और आपका सिलेक्शन हो जाएगा? सब कुछ आपके ऊपर डिपेंड करता है. ठीक है? I'm just giving you what? I'm just giving you a direction, nothing else. ठीक है? पढ़ना तो आप ही को है ना, और पहला ही रूल का ब्रेक हो रहा है, ठीक है? नहीं, आप इसको देखो तो कम से कम कौन सा पेज है, क्या मटेरियल हम पढ़ने जा रहे हैं, कौन सा टॉपिक है। यू ऑलरेडी न्यू दैट विच टॉपिक इज गोइंग टू बी कवर्ड टुडे, ठीक है? तो एक रीडिंग तो बनता ही है, ठीक है? कितना घंटा लग जाएगा? आधा घंटा, 1 घंटा, बहुत ज्यादा होगा तो, ठीक है? रीडिंग, मैंने बोला रीडिंग, समझ में आया ना आया मुझे परवाह नहीं है, ठीक है? रीडिंग कभी कभी 2 मिनट भी मिलता है तो ऐसे देख के आ जाना बस, ठीक है? हाँ चलो क्लास जाने का टाइम हो गया, है ना? कम से कम पता तो रहेगा कि अंदर में है क्या, ठीक है? फॉर सम ऑफ द टॉपिक्स आई हैव प्रोवाइडेड यू एडिशनल मटेरियल, ठीक है? कुछ हैंड रिटन भी डाल दिया और थोड़ा सा प्रिंटेड भी उसमें रखा, ताकि ये इंश्योर कर सकूं कि आपको ज्यादा से ज्यादा, क्योंकि बहुत मतलब इंटीरियर ऑफ अर्थ का एक ऐसा पार्ट है जहाँ पे कुछ कह सकते हैं कि 100% कन्विक्शन से हम कुछ नहीं कह सकते, ठीक है? कि ऐसा ही हो रहा हो, है ना? तो जनरलाइजेशन जहाँ पे हो रहा है तो अलग अलग you find different sources, right? Different sources taking different right? Different limits of earth interior and accordingly classifying the earth interior, ठीक है? तो इसलिए मैंने सारा कुछ आपको यहाँ पे दिया ताकि आपको एक जनरल आइडिया हो जाए कि हाँ आपको अगेन यू डोंट हैव टू बिहेव लाइक ए ज्योग्राफर और ए जियोलॉजिस्ट, राइट? आपको जियोलॉजिस्ट तो बनना नहीं है, ठीक है ना? बात समझ में आ रहा है ना? जियोलॉजिस्ट नहीं बनना है, लेकिन if they ask you about the earth interior, you should have a picture in your mind, right? What you know about the earth interior, right? And your knowledge, your understanding is based on what, right? Do you have any supportive evidence? क्योंकि आपके एग्जाम में आपको आंसर में वही लिखना है, ठीक है? Nobody is interested in fact, आपको वही लिखना है कि क्यों ऐसा है, ठीक है? Why the earth is behaving the way it is behaving, right? If it is a solid body, right, more or less a solid body, then why it is a solid body, right? Which are the factors which are responsible for keeping the earth interior in a solid state, ठीक है? तो आपको जनरल पिक्चर तो दिमाग में बनाना पड़ेगा, तो एक बार देखिए, तो इसको देखना है आपको। अब डायग्राम जो सी डायग्राम है, डायग्राम सी देखिए, वहां पे क्या देख रहे हो आप? कैसे जा रहा है? लेफ्ट फिर राइट, एरो को ध्यान देना, एरो कैसे है? ऐसे, लेफ्ट फिर राइट, ठीक है? तो दिस इज योर कर्व पैटर्न ऑफ मूवमेंट, राइट? मियांड्रिंग पैटर्न ऑफ मूवमेंट, है ना? जिगजैग पैटर्न ऑफ मूवमेंट, ठीक है? उसी को हम लोग बोलते हैं लव वेव्स, है ना? क्लियर? तो ऐसे भी आपको पता है कि लव वेव, राइट? लव द वर्ड इटसेल्फ इज वेरी डिस्ट्रक्टिव, यस नो? तो लव क्या होता है? इधर उधर देखता है ना, बाएं दाएं, तो उसको ध्यान रखना है कि दिस इज योर लव वेव, दैट्स इट, है ना? और इससे ज्यादा मेरे बोलने का मेरा राइट नहीं है, ठीक है? तो दिस इज योर लव वेव। कमिंग टू रेलिक वेव कैसे होते हैं? अब उनको देखना, क्या करेंगे? ये सरफेस पे चल रहे हैं, वो क्या करेंगे? They move as what? Waves, right? Having small crest and trough, ठीक है? देखना है वो डायग्राम, ठीक है? तो क्या हो रहा है? Vertical rise and fall, yes or no? Vertical rise and fall. So the wave particle inside the relic wave, they rise and fall, just like your secondary wave, right? The only difference is the secondary wave is operating inside the earth, right? Yes or no? Secondary wave is operating inside the earth, and here you have one wave which is operating only on the surface of earth, right? And it has a wavy nature of movement, right? Rise and fall, small crest and trough, not as the crest and trough we see in the case of secondary wave. They are more intense, है ना? They are more intense. They are the original energy waves, right? They are not the secondary waves, ठीक है? वो क्या है? Primary waves है. Primary मतलब I'm making that classification further between body and surface wave, right? Body wave, either P or S wave, both waves are what? Primary waves. They are the primary source of energy, right? Whereas surface waves are secondary energy wave, ठीक है ना? तो इसलिए उसमें इंटेंसिटी इतना ज्यादा नहीं होगा, राइट? सो दिस इज योर लव एंड रेलिक वेव. So now we know the properties of P and S wave, because we have to rely upon the body wave to scan the earth interior. before we start scanning the earth interior, let us have a broad understanding about the cross section, right? Cross section of earth interior, because whenever I start the story of P and S wave, you will be able to comprehend, you will be able to understand what I am talking about. Okay? So we know that on the basis of the study, I said study made upon the seismic wave, observing their velocity, observing their travel path, we are able to classify, we are able to divide the earth into three broad layers, that is crust, mantle and core, right? These three broad layers are further subdivided, right? I told you. So let us understand first of all the cross section of earth interior, right? What are the cross section of earth interior and what is their depth? Depth कितना है? ठीक है? What is their dimension? So this is your 0 kilometer. ये हमारा 0 kilometer है earth surface, right? And the uppermost layer of the earth interior, is crust, which is taken at an average depth of 35 kilometers. Okay, average depth है. Why I am saying average depth? Because you know that the crust is not having same thickness everywhere, right? बोलना नहीं है crust कैसा है. अभी आपने कल ही आप लोगों ने पढ़ा है, क्या पढ़ा है? What you have studied? अरे कल ही तो आप लोगों ने पढ़ा है ना, क्या पढ़ा है? अर्थ क्रस्ट क्या होता है? Oceanic crust and continental crust, right? So obviously the oceanic crust would be thinner. अरे हाँ या ना? The average depth of the oceanic crust is 5 kilometers. ठीक है? Whereas the continental crust and the depth of the continental crust goes up to almost 70 kilometers in the Himalayan zone. ठीक है? तो दोनों का एवरेज लेके हम कितना लेते हैं? 35 किलोमीटर. दैट इज द एवरेज डेप्थ. ठीक है? एवरेज डेप्थ. तो ऐसा डायमेंशन आपको दिखा रहा हूँ, एक्चुअली ऐसा तो नहीं है अर्थ क्रस्ट, मालूम है आपको. ठीक है? दैट इज हैविंग बोथ कॉन्टिनेंटल एंड ओशियनिक पार्ट. आई एम नॉट मेकिंग इट कॉम्प्लेक्स हियर, so we'll avoid talking about all those things. We have to deal with those things later on. So this is your crust, right? Then the boundary between the boundary between crust, I said the boundary between crust and mantle is between, or the boundary between crust and mantle is located at an average depth of 35 kilometers, and that boundary that lies between mantle and the innermost layer of the earth interior, that is your core, that is located at 2900 kilometers of depth. That is 2900 kilometers. Okay? Then this core is further subdivided into outer core and inner core, because the core behaves in a what unexpected manner, right? इसलिए हम लोग इसका दो डिवीजन देखेंगे, that is your outer core and inner core, right? So outer core and inner core, the boundary lies where? The boundary lies at a depth of 5150 kilometer. This is your boundary between outer core and inner core. ठीक है? And you already know the center of the earth, that is 6371 kilometer. ठीक है? So these are the broad dimensions of earth we have, that is broad dimension of earth interior. And we are going to see how the seismic waves behave. I said how the seismic wave behave inside the earth. कैसे काम करते हैं? ठीक है? हम लोगों को ध्यान क्या रखना है कि the information we have derived from the study of seismic wave, right? By observing their velocity, their travel path, we have been able to classify the earth interior into three broad layers: crust, mantle and core. ठीक है ना? अब हम लोग इसका ये देखने वाले हैं कि तीनों broad layers में, ठीक है, कैसे right from the point of origination of the seismic wave, that is focus, how the seismic wave, that is P and S wave, is behaving at different depth of earth interior, right? So we have to follow the whole story. ठीक है? So don't assume that I am Sam acting over smart here, right? First of all, I am saying to you that I am Sam going to talk about the structure of earth interior, and that structure is purely based on the knowledge we get from the study of seismic wave, okay? Right? But it is not possible to so clearly their behavior if we do not take into account the broad layers of earth interior. I'll remove those layers later on, right? And then I'll highlight how we have been able to classify the earth interior. I said classify the earth interior, and again I'm repeating that is purely based on the observation of seismic wave, ठीक है? सारा इंफॉर्मेशन seismic wave से ही हमको आ रहा है, ठीक है? तो हम लोग जो लेयर पहले लेंगे वो किस लिए ले रहे हैं? This is just for our convenience, right? Convenience to see the behavior and the changing velocity of seismic wave at different depth of earth interior in a transparent manner. थोड़ा clear तरीके से हम लोग देख पाए, ठीक है? इसके लिए हम लोग लेयर पहले ले लेंगे. So these are your broad layers inside the earth. Now coming to the scanning part, we'll now scan the earth interior, and I'm taking this at 0 degree longitude. This is the point, right, from where I'm going to see the origination of the seismic wave, okay? So this is your 0 degree. You can take that point anywhere. यहाँ भी ले सकते हो, यहाँ भी आपका जहाँ मन करे, ठीक है? तो मैंने यहाँ पे लिया, तो antipodal point of that 0 degree, that means the opposite point, antipodal, right? Or you can say anti point. Anti point of 0 degree would be 180 degree. Yes or no? Earth is a spherical body, more or less, right? More or less a spherical body. अभी तो मैंने shape का भी बात नहीं किया. When I start with climatology, I talk about shape, rotation, revolution, all those things, right? तो यहाँ पे ठीक है, यहाँ पे हमको ध्यान रखना है कि Earth is more or less a spherical body, right? And if this is the point, right? Point we are taking as the reference point for the location of the focus, then the antifocal point, right? The anti-focus or the anti-point of 0 degree would be 180 degree, okay? Now, we all know that focus is located where? Focus is always located inside the earth, okay? The deepest point up to which a focus is recognized or that has been observed, that has been recorded, it says 700 kilometer, I told you, okay? So focus is always located inside the earth, and epicenter is found where? Epicenter is found where? On the surface of earth, right? Just above the focus, right? Just above the focus. तो epicenter को याद रखना अलग होता है, उससे हमको कोई लेना देना नहीं है, ठीक है? हम लोग किस पे फोकस करेंगे? सिर्फ फोकस पे, ठीक है? तो this is your focus, and now the seismic waves are generated, ठीक है? Focus हो गया, and then seismic waves are generated. They will travel in all directions, right? They will travel in all directions, right? Because you know the seismic waves are guided by two principles of motion. Two principles of motion. One is refraction, the other is reflection. ठीक है? तो दोनों का refraction भी होगा, reflection भी होगा, है ना? तो let us talk about the journey of P waves inside the earth. And as I said, for our convenience to understand and see their behavior more clearly, we are taking those broad layers inside the earth. This is the uppermost layer, that is crust, and then we are taking one more layer here, that is outer core and inner core. You know the depth, अभी boundary आपको पता है, ठीक है? So what happens to P waves? How P wave will behave? So once you have focus here, you know that seismic wave could travel in all directions. Seismic waves will move in all directions. Yes, they would be They would be refracted and they would be reflected. Okay, they travel in all directions. both, right? PS, 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 PS like this. ठीक है? All direction. Fine. Now we have to, right? I said we have to study the journey of the P wave, right from the near the surface zone, that means right from the focus to the center of the earth. Okay? Because this is your P wave which is able to pass through all, which is able to pass through all state of matter, and that is recorded till the center of earth, right? Till the center of earth. So how the P waves behave at different depth of earth interior, let us see that. और कहाँ से हमको सारा डेटा मिल रहा है? You know, I told you सिस्मोग्राम क्या इंस्ट्रूमेंट है, ठीक है ना, जिसमें कि पेंडुलम बॉल होता है और वो हिट करते रहता है. And the graphical representation of the data, data recorded by seismogram is presented over seismograph, right? जैसे आपने देखा ना ECG कराते हैं कभी, हार्ट का ECG होता है ना, तो आप देखते हैं ना ऐसे, ठीक है ना, तो वो waves का जो graphical representation है, that is done by an instrument we call it as seismograph, right? इसीलिए graph पे याद रखना, graph and gram, right? Gram is a mechanical instrument, ठीक है, वो मैकेनिकल इंस्ट्रूमेंट है, और ग्राफ क्या है? दैट इज द graphical reproduction of the data, data collected by seismogram. So one seismograph may be dependent upon many of the seismogram, बहुत सारे seismogram हो सकते हैं, ठीक है. It is collecting data from many seismogram. और seismogram में क्या होता है, अब थोड़ा सा इसमें बोल देता हूँ. Seismogram collects data, collects data wherever you have the data shown along x and y axis, ठीक है. X axis represent time and y axis represent ground displacement. ठीक है. तो टाइम क्या है? टाइम कितने बजे कौन सा सिस्मिक वेव आया, ठीक है. तो द टाइम इज रिप्रेजेंटेड इन सेकंड्स एंड ग्राउंड डिस्प्लेसमेंट इज रिप्रेजेंटेड इन दैट इज रिप्रेजेंटेड इन मिलीमीटर, ठीक है. ग्राउंड डिस्प्लेसमेंट मतलब कितना सेकिंग हुआ, ठीक है. तो अब जैसे मान लो टाइम पे आ गया, कोई वेव रिकॉर्ड हो गया यहाँ पे, सबसे पहले कौन सा रिकॉर्ड आएगा? मालूम है कौन सा यहाँ पे रिकॉर्ड आने वाला है? पी वेव का. तो पी वेव का रिकॉर्ड आ गया, तो ग्राउंड डिस्प्लेसमेंट क्या दिखाएंगे आप? ग्राउंड डिस्प्लेसमेंट कैसा दिखेगा? द ग्राउंड डिस्प्लेसमेंट वुड बी लाइक दिस. फिर एस वेव आ गया, मान लो एस वेव 20 सेकंड्स के बाद आया, तो ग्राउंड डिस्प्लेसमेंट कैसा दिखेगा? ऐसा. मान लो फिर सरफेस वेव, तो ग्राउंड डिस्प्लेसमेंट कैसा दिखेगा? बस समझ में आ रहा है? तो this is your y axis, that is representing what? Ground displacement. The x axis is representing the time, ठीक है. The time of the arrival of those seismic waves. इतना डिटेल आपको नहीं जानना है, फिर से मैं बोल रहा हूँ कि you are not going to become a geophysicist, right? ठीक है. Even I do not consider myself as a geographer, right? तो मेरा सिर्फ मानना है कि I am still a student of geography, right? And this is what you have to consider, right? And this is what you have to achieve for yourself, ठीक है ना. कोई इतना इमोशनल होने का भी जरूरत नहीं कि मैं ज्योग्राफर या ज्योग्राफी का बहुत अच्छा स्टूडेंट हूँ, कोई काम का नहीं है. इफ यू आर नॉट एबल टू क्रैक दिस एग्जामिनेशन, बिलीव मी, ठीक है ना. फिर तो ऐसे भटकते रहोगे, माउंटेन दिखाई देगा, रिवर दिखाई देगा, और उधर ही डूबने का मन करेगा. अरे हाँ ना, अरे सुनो, तो मरने का ख्याल बहुत आएगा आपको, ठीक है. ये क्या किया, मैंने जिंदगी बर्बाद कर लिया. तो इसीलिए इतना इमोशनल नहीं होना है. हमेशा एक ही बात मैंने बार बोला है, स्टिक टू द प्लान, ठीक है. जब भी कंफ्यूजन हो, दिमाग में एक ही बात बोलना है, ठीक है. गो टू द बेसिक्स. हमेशा ध्यान रखो कि क्या मैं क्वेश्चन अटेम्प्ट कर पा रहा हूँ, ठीक है. एंड द बेस्ट वे टू जज इट इज बाय सीइंग द प्रीवियस क्वेश्चन, राइट. प्रीवियस क्वेश्चन को देखिए, है ना. यूपीएससी का क्वेश्चन सबसे स्टैंडर्ड क्वेश्चन है, उससे मतलब दुनिया का सेकंड टफेस्ट एग्जामिनेशन है ना. Why I'm saying second toughest examination? Because I consider the toughest examination in the world is the examination held by APPSC. Yes or no? Because there is no rule fixed ना, rule ही नहीं है fixed. कब एग्जाम होगा ये भी पता. हाँ, पता चला आज शादी किया, कल बच्चा 5 साल 7 साल का हो गया, तब भी एग्जाम नहीं होगा. हाँ, इंतजार करते करते बच्चा बड़ा हो गया, अब वो बोल रहा पापा अपना किताब हमको दे दो। अब मेरा टाइम आ गया, अब जाओ, एक्सपायर हो गया, पापा इंतजार में ही रह गए, है ना। उधर मम्मी भी परेशान, ठीक है। अरे ऐसे ही होता है ना, पूरा पूरा एक डिकेड भी निकल जाता है कहीं कहीं पे तो, ठीक है। 5-6 साल मैंने तो पता नहीं आप लोग कहानी बताया नहीं बताया, पर राइट मेरे ख्याल से बताया होगा कि राइट आई टुक माई एग्जामिनेशन इन बीपीएससी इन द ईयर 2013 और 5 साल के बाद रिजल्ट आया, है ना, 2018। तब तो मैं भूल ही गया था, बीच में मेंस हुआ था 2015 में, but I was not at all worried about my result, क्योंकि पता था कि हाँ ठीक है चलो, because you have social compulsion, right, family compulsion, बहुत कुछ होता है, तो चलो एग्जाम दे देते हैं। तो एग्जाम देने का तो मूड भी नहीं था। 2013 सोचो, और 5 साल निकल गया। 2015 में मेंस हुआ एंड देन इट गॉट डिलेड बाय डिफरेंट रीजंस, ठीक है। कहीं पेपर लीक हो रहा है, तो कहीं पे एक ऑप्शनल, मान लो एक ऑप्शनल था हिस्ट्री ऑप्शनल, तो हिस्ट्री में क्या पूछा गया, हिस्ट्री में जूलॉजी का क्वेश्चन पूछा गया पेपर 2। तो हिस्ट्री वालों ने हंगामा कर दिया कि नहीं कैंसिल करो, तो हिस्ट्री ऑप्शन वाज कैंसिल्ड, जूलॉजी वाज कैंसिल्ड, राइट, पब्लिक एडमिनिस्ट्रेशन एंड पॉलिटिकल साइंस वाज आल्सो कैंसिल्ड, ठीक है। दैट मींस द एग्जामिनेशन वाज रीहेल्ड, फिर से हुआ दोबारा। थैंक गॉड देयर वाज नो रिपीटेशन फॉर ज्योग्राफी, ठीक है। ज्योग्राफी कैंसिल नहीं हुआ, तो मुझे दोबारा जाना नहीं पड़ा। मतलब 2015 से लेके 17 तक सब लोग मेंस ही दे रहे बार-बार, ठीक है। और फाइनली उसका रिजल्ट आया 2018 में। फिर मैं ऐसे ही क्लास लेके रात 7:30 बज रहा था, आई वाज इन आबोतानी कॉलोनी, मतलब घर जा रहा था, तो मेरे दोस्त ने किसी ने फोन किया मुझे, मेरा दोस्त जो मतलब दोस्त कैजुअल था, हम लोग साथ में मिले थे, एंड देन वी टुक आवर एग्जामिनेशन टुगेदर, वी लेफ्ट इन द सेम होटल, तो थोड़ा जान पहचान हम लोग का हो गया था। पर देखो कभी कभी गहरा दोस्ती काम नहीं करता है, कभी कभी कैजुअल दोस्त जो होते हैं वो ज्यादा काम आते हैं, ठीक है। तो बोला दोस्त आपका मालूम है आपको कि आपका रिजल्ट आ गया है। मैं बोला रिजल्ट कौन सा? तो बोला कि बीपीएससी मेंस। हाँ, बीपीएससी मेंस। बोला कौन सा बीपीएससी यार बोलो। तो उनको यकीन नहीं हो रहा था क्या बात कर रहा, तो दिमाग में नहीं, मतलब आउट हो गया एकदम बाहर, मतलब सोच लिया कि कुछ नहीं करना है। इतना इंटरव्यू देख के पागल हो गया, अब नहीं चाहिए। वो लोग को मेरा चेहरा पसंद नहीं, हमको वो लोग पसंद है, ठीक है, नहीं चाहिए हमको। फाइनली ही सेड टू मी, क्योंकि मेरे पास तो एडमिट कार्ड भी नहीं है ना, रोल नंबर कहाँ से देखूंगा, ठीक है। मेरे पास कुछ है ही नहीं है, सब कुछ कहाँ है, बेकार ही था, लेकिन कहीं मिल ही नहीं सकता, कहाँ है मालूम नहीं। तो उसने बोला चिंता नहीं करना दोस्त, तुम्हारा रोल नंबर मेरे पास है। मैंने बोला वाह। तो उसने मेरा रोल नंबर देखा और बोला बस 2 मिनट देना दोस्त, 2 मिनट होल्ड करो। हम बोले होल्ड नहीं कर सकते, तुम फोन करो, हम घर का ताला, मतलब ताला खोलने वाले, हमको प्यास लग रहा है, हम अंदर जा रहे हैं। उसका बस 2 मिनट के अंदर में फोन आ गया और उसने बोला कि दोस्त बधाई हो, मतलब सिलेक्शन हो गया, ठीक है। देन आई वेंट फॉर इंटरव्यू के लिए चले गए, ठीक है। उसमें मैं भी सोच रहा हूँ कि जाओ ना जाओ, ठीक है। लेकिन मेरा जानने से पहले मेरा घर वालों को पता चल गया है, बिकॉज माई फादर ऑल्सो सेव्ड माई रोल नंबर। द सेकेंड डे इट वॉज पब्लिश्ड इन द न्यूज़पेपर, और उन्होंने देखा वाह रोल नंबर, और देखते साथ उन्होंने पूरा मोहल्ला बता दिया वाह आज आया है आसमान से गिरा खजूर पे लटका है। यूपीएससी करने गया तो कोई बात नहीं, बीपीएससी में तो हो जाएगा। हाँ, 4 बार झारखंड का इंटरव्यू दिया, कोई बात नहीं, अभी तो मरते मरते इसका सिलेक्शन तो होगा, ठीक है। Because I asked my father in 2008 when I expired all my attempts in UPSC to give me some land holding. मैंने बोला 4-5 बीघा जमीन दे दो, पुश्तैनी जमीन, मतलब एंसेस्ट्रल जमीन हम लोग का 20-25 बीघा जमीन होगा। तो मैंने बोला बिहार में जो जमीन पाओ में कौन सा बिहार, कैसा बिहार, कौन सा पुश्तैनी जमीन, तो तुम्हारा कुछ नहीं है, ठीक है। Because I wanted to pursue agriculture, farming. मैंने बोला मैं इंडिपेंडेंट, बिकॉज यार अब 32-33 साल का उम्र हो गया, एंड देन आई कैन नॉट गो टू द कॉर्पोरेट पोस्ट, ठीक है। जो मेरा बॉस होगा वो 22-23 साल का होगा, और वो कौन होगा मालूम है, टीम लीडर, और मैं क्या होगा मालूम है, ठीक है। वो बकवास करता रहेगा और मेरा दिमाग खराब होता रहेगा। वो तो मालूम था कि ये सब हमसे होने वाला नहीं, ठीक है। आई एम ए पर्सन विद लिमिटेड स्किल्स, ठीक है। तो मैंने इसलिए मतलब बहुत निराश था, मतलब आई वाज started in 2008 when I took my interview in UPSC, the last interview, and it was also the last interview in Jharkhand, right? because after that I never took Jharkhand PCS examination. कभी दिया नहीं, बिहार भी नहीं दिया. It was just after 1 or 2 years that out of self realization लगा कि चलो कुछ कर ही देना चाहिए, क्या बुरा है. Because my father used to say कि अरे थोड़ा कोई बात नहीं, बीपीएससी कर लो, कहीं तो सिलेक्शन होना चाहिए. तो मैंने फुल फॉर्म भरा 2013 में, ठीक है, आफ्टर 5 years, क्योंकि 5 साल बहुत होता है, सब कुछ उल्टा पुल्टा जो हुआ है वो सब ठीक होने में. तो फाइनली आई मीन आई वेट फॉर द इंटरव्यू, और इंटरव्यू शुरू हो गया. एंड देन फाइनली दे आस्क्ड मी कि ओके डियर राजीव, आप मुझे ये बताइए कि हिंदी में ही बात हो रहा था, तो उन्होंने बोला कि अच्छा टेल मी वेर यू वर फॉर लास्ट 15 years. तो मैंने बोला 15 years मतलब मुझे लगा इतना मैं बूढ़ा हो गया क्या. तो बोला यस यू ग्रेजुएटेड इन 2000, राइट, यू डिड योर पोस्ट ग्रेजुएशन इन 2004, राइट. फिर आप अभी तक थे कहाँ पे, इस यूनिवर्स में कहाँ खोए हुए थे आप? आपको पता है कि आप कहीं थे? तो मैंने बोला कि सर कुछ काम कर रहा था. तो बोले नहीं वो सब नहीं जानना है, मतलब रोजी रोटी कैसे चल रहा था, मतलब ब्रेड एंड बटर, खाना पीना. बोला सर घर से पैसा वैसा आता था, तब तक पढ़ाई चल रहा था दिल्ली यूनिवर्सिटी में, तब तक अच्छे दिन थे, ठीक है. और जब ये रियलाइजेशन हुआ कि बहुत हो गया, पापा से पैसा नहीं लेना है, उसी दिन से बुरा दिन शुरू हो गया, ठीक है. रियलाइजेशन बहुत खराब चीज होता है ना, जब तक आप गधे हैं तो अच्छा रहते हैं आप, ठीक है. तो आई सेड कि सर आई एम इन्वॉल्व इन ए कोचिंग इंस्टीट्यूट, तो आई टेक क्लासेस फॉर सिविल सर्विसेज कोचिंग. और जैसे मैंने बोला कि सिविल सर्विसेज कोचिंग एंड देन सेड ओके व्हाट इज द नेम ऑफ द इंस्टीट्यूट. तो मैंने बोला, बताया, उसका नाम बोलना ठीक नहीं लगेगा अभी. तो उन्होंने फिर बोला कि अच्छा वेयर दैट इज लोकेटेड. तो मैंने बोला सर इट इज इन ईटानगर, अरुणाचल प्रदेश. द मोमेंट आई सेड अरुणाचल प्रदेश, दे बिकेम so excited that they wanted to know everything about me. And the whole interview was now according to my profile, right? Okay, tell us 5 major tribes of Arunachal Pradesh. आइए भाई साहब, आइए पूछिए, ठीक है. हाईएस्ट पीक, मतलब उनको जो समझ में आ रहा है वो पूछ रहे हैं, ठीक है. What are the major sectors of economic activity in Arunachal Pradesh? यही सारा बात वो लोग पूछ रहे हैं. मतलब 15 मिनट मेरा अरुणाचल प्रदेश पे चला. फिर उसके बाद फिर देखो कैसा चल रहा है, मेरा ही ऊपर हो रहा है क्वेश्चन. मतलब बताओ, अच्छा तुम कोचिंग करते थे तो क्या क्या पढ़ाते थे? तो मैंने बोला कि ज्योग्राफी. तो ज्योग्राफी में शायद उन लोगों को लगा नहीं कि कुछ क्वेश्चन पूछना चाहिए, फिर क्वेश्चन नहीं बना दिमाग में, जो भी है. मतलब और क्या पढ़ाते थे? बोले पॉलिटी और इकोनॉमी. हमने सर हिस्ट्री छोड़ के सब कुछ पढ़ाया. तो बोले अच्छा तो बताओ डीमोनेटाइजेशन का 3 बेनिफिट बताओ. डीमोनेटाइजेशन, ठीक है. तो मैंने बताया. बोला अच्छा ठीक है, बहुत अच्छा, ठीक है राजीव, थैंक यू. हाथ मिला हम लोगों ने और मैं वापस आ गया. दैट वाज द फर्स्ट एंड द लास्ट इंटरव्यू ऑफ माय लाइफ व्हेन आई सिक्योर्ड 75% मार्क्स इन इंटरव्यू. नेवर एवर इन माय लाइफ आई सिक्योर्ड मोर देन 33% मार्क्स. नेवर एवर, ठीक है. क्योंकि मेरा चेहरा ही खतरनाक है. जैसे मैं बोर्ड में जाता हूँ, वो मुझे देख के वो लोग पता नहीं क्या होता है, ठीक है. और खास करके जो वहाँ लेडी मेंबर अगर कोई बैठे है ना, वो तो मुझे छोड़ने वाला है. पता लगता है जैसे मैं उसका रिश्तेदार हूँ, ठीक है. यूपीएससी आई रिमेंबर आई वाज जस्ट ब्लैंक, पागल बना दिया था उसको, ठीक है. कि बताओ फाइल कैसे जा रहा है. मुझे भाई मैं तो पहले एडमिनिस्ट्रेशन में जाने तो दो, ठीक है. तो आई जस्ट टॉक अबाउट द जनरल प्रोसीड्यूर, ठीक है. कि भाई डीलिंग असिस्टेंट होता है, प्रिंसिपल असिस्टेंट होता है, फिर लोअर लेवल से हायर लेवल पे जाता है, स्क्रूटनी होता है, देन अगेन इट कैन कम बैक. मतलब बेसिक आंसर जो होता है, ठीक है. तो बोले नहीं, आई वांट द स्पेसिफिक आंसर. मैं बोला आई डोंट नो मैम. बोला ओके फाइन, अदर मेंबर्स यू टेक, ठीक है. तो ऐसा होता है कि समटाइम द सिचुएशन बिकम्स फेवरेबल फॉर यू, ठीक है. तो कारण इसमें क्या है? सिलेक्शन का भी कारण मेरा अरुणाचल प्रदेश ही था, ठीक है ना. बिकॉज आई सिक्योर्ड गुड मार्क्स इन मेंस, बट इट वाज नॉट आउटस्टैंडिंग, ठीक है. जस्ट लाइक यूपीएससी में आउटस्टैंडिंग मार्क्स थे, बट इंटरव्यू वाज ए डैम्पनर ना. तो इसमें मार्क्स अगर अच्छा 75% मार्क्स मिला तो आई गॉट गुड रैंकिंग, है ना. अगर यहाँ पे मान लो 60% होता, 50% होता तो सिलेक्शन तो हो जाता, बट इतना अच्छा रैंक नहीं होता. तो इसलिए मैंने बोला कि अरुणाचल की वजह से सिलेक्शन हुआ और फिर मालूम है द स्पिरिट ऑफ अरुणाचल प्रदेश हॉन्टेड मी फॉर ऑलमोस्ट 9 months। हाँ, कि क्या क्या करूँ, यहाँ तो जिंदगी बर्बाद सा लग रहा है, ठीक है, क्योंकि हर काम उल्टा पुल्टा है, ठीक है। तो वो आई स्टेड फॉर 9 months, ठीक है। एनी हाउ बियरिंग those pressure, right? I mean got suspended for 3 times in 9 months, ठीक है। और जितना बार सस्पेंशन हो उतना मुझे खुशी हो कि चलो सस्पेंशन कर दिया, अब तो मेरा कोई जिम्मेवारी ही नहीं है ना। तो आई यूज्ड टू रन अवे फ्रॉम द हेडक्वार्टर्स, राइट, एंड स्टेशन माई सेल्फ इन दिल्ली विद माई फैमिली, छोड़ो बाहर में जाने दो, ठीक है। तो स्टिल यू वोंट बिलीव आफ्टर टेंडरिंग माई रेजिग्नेशन, जब मैंने रेजिग्नेशन दिया, एक बार नहीं 2 बार दिया, तो डिपार्टमेंट डिड नॉट एक्सेप्ट दिस, क्योंकि मेरा लैंग्वेज कैसा था, बिकॉज ऑफ अब समझना है लैंग्वेज कैसा है। ऐसा नहीं है कि मैंने कुछ बहुत हार्श लैंग्वेज था, बट उसमें मैंने हिंदी में लिखा, हिंदी का ही प्रयोग ज्यादा होता है।